Hello, everyone, and thank you for your time today. I'm Sudeep Charles, and I head product marketing for Chef Desktop. With me today is Nishchal Reddy, who heads product management for this product, as well as Rishi Chowda from our engineering team. Right. The one thing that I do want to add is housekeeping. Is feel free to ask questions in the Q&A interface that you have, and we'll pick them up towards the end of the webinar, right? So with that said, over the next hour, we'll cover an overview of Zero Trust. We'll see how this paradigm can be orchestrated with Chef Desktop and the benefits that you can derive from this approach, right? So, and then finally, we'll wrap this up with a demo to give you a sense of how Chef can be used to orchestrate Zero Trust. Well, with that said, let's get to it. But a Gartner survey recently surveyed about 317 odd CFOs and finance leaders and revealed that about 74% of them will move at least, and that's at least 5% of their previously on-site workforce to their remote positions post COVID-19, right? Which is 5% still seems okay. But in fact, nearly a quarter of those respondents said that they would move at least 20% of their on-site employees to remote positions, right? Not come in to work at a centralized location. And an additional 13% of these respondents noted that there's already cost considerations underway in real estate expenses, and 9% are taking actions to kind of move away from actually investing in real estate. What does this mean, right? What is the impact of all of this? Essentially this, right? So there is going to be an evolving set of business models. The ecosystem is also going to evolve. Businesses are going to do business very differently. Employees, customers are going to interact with businesses differently. And this will impact the way technology is used, right? So it's going to lead to a rapid change in the way technology is being used. While all of this happens, and you perhaps know this best, regulatory regimes are not getting any easier to deal with, right? So there's going to be more auditing, tighter auditing, and we're expected to keep to those standards. And I'm not even going to talk about disruptive events in the context of COVID, right? But all of these drivers necessarily give up or provide a set of requirements that we'll need to address, right? And that is increased agility in the business. And a lot of other companies are faster to adopt to market changes. How can each one of us do that and keep pace? There's increasing complexity, both with technology, with our employees, with the kind of systems that they use, the kind of operating systems that they use. There is, of course, the small problem of a distributed workforce. And of course, threats are evolving in real time. Ability to keep on top of those threats, visibility of those threats, ability to pass audits while all of this is going on is something that each one of us will have to deal with in our capacities, right? So that said, just a quick sense of the kind of assumptions that the traditional approach to security has had, right? And I'll list these out, and you'll almost instantly relate to the fact that none of this actually holds true. Every endpoint, being used to access resources was typically owned, issued, or managed by the enterprise. This is no longer true, right? All users, devices, and applications were in fixed, predictable locations, and that typically meant in a corporate network, preferably behind a firewall. That's not true either. A single method of verification was typically used, usually at the point of access, right? You just validate once, hey, is this the right guy? Is he got the right set of privileges? And if he did pass those checks, he was good to go in, and that led to the next assumption, which was he or she could potentially access all other systems inherently, right? And do so laterally. So there was lateral transport, if you will, of attack vectors. And all of this is, of course, is not true anymore. The bring your own device, or I tend to joke with colleagues, bring your own disaster is well in the making, right? Cloud, increased collaboration, amongst partners. Typically, the consumerization of IT has led to the proliferation of devices, and that is in itself a challenge, right? And therefore, the traditional way of dealing with threats no longer is true. You therefore need a trust paradigm in dealing with these new business imperatives. Zero trust essentially is an IT paradigm that requires, strict identity verification for every person or device that's trying to access resources on a private network, regardless of where they're sitting, whether within or without the network perimeter. And there is no single specific technology that is associated with zero trust, right? It's a holistic approach. There are multiple technologies that make it possible, and Chef Desktop is one such, right? Well, very quickly, right? In terms of the broad differences between the traditional approach and the zero trust approach, there are pretty much three key differences. Trust is no longer based on the location of the request, but it is established every time a request is made of a given resource, right? Lateral traversal of attacks is typically restricted, and I said this earlier in the session, right? And it's based typically on tightly enforced profiles. Static perimeters are a thing of the past; they're no longer true, and zero trust enables the modern enterprise. And all of these are key differences that necessitate the kind of technology that we're going to speak about today. Well, three pillars of zero trust, and I'll quickly enumerate them. The first is a basic paradigm where zero trust will authenticate and verify every access to resources, right? You re-authenticate a user's access every time a resource request is made. And you have to assume that every attempt to access your network is a threat until it is confirmed otherwise, regardless of location, of the kind of hosting model, the kind of device that you use, right? And you need to be able to implement and access protocols that support this. The least privilege access concept is something that zero trust employs. What is the least possible privilege that you can give to your end users that will enable them to do their jobs well? And what does this mean? I mean, it could potentially mean something like, hey, create new groups and assign data owners to manage these groups, use these new groups to implement least privilege access. You could audit access and group memberships on a regular schedule, on a regular basis, put data owners in charge of, who's going to access the data and in what manner, right? All of that is possible, or it's encompassed in this pillar. And finally, of course, zero trust principles require the inspection and verification of everything, right? So logging every network call, file access, email for malicious activity is something that this paradigm insists on. And this is arguably the most important, or one of the most important capabilities that you would have in enforcing zero trust, right? With monitoring and data security analytics in place, you can tell the difference between a normal login and a malicious or a compromised account, right? And that's the third key pillar to zero trust. Well, what does this mean in the way Chef approaches this, right? And again, you can tell I'm a fan of three things, right? So three major components to it. One is establishing trust, right? Devices that are within your network are identified and checked, and you get regular status of these devices from time to time. And after you validate the device context and its identity, the health and status of those devices alongside those relevant attributes can be monitored regularly, right? You're enforcing trust-based access. Users are granted access to only those applications and resources which they are allowed to access based on their profiles. And of course, there is continuous trust verification, right? Policy enforcement is stringent. Users are asked to change their passwords, and that's again based on policy. IT managers can keep an eye, on the listed devices that have continuously checked in. What is their behavior like? What is their current status like? What is their current state like, right? And keep an eye on the current status of these nodes. So all of that is possible with Chef Desktop. And we'll talk a little bit about that. But quickly, right? This gives you a bunch of benefits. One, you can stop lateral movement of threat vectors, right? It's centrally managed. It's a single console, single pane of glass. gives you that kind of visibility. There is the optional but provided inspection of log items that you can look at. It's a seamless user experience, right? So it doesn't really add to end user overhead in terms of the way they interact with their devices. And of course, it helps you deploy policies and conditional access to certain resources while restricting access to high value resources that are compliant or on managed devices, right? So with that said, we'll move to the next section. But before we do that, you'll see a poll question pop up. Please do take time to respond to that, and we'll discuss those results towards the end of this webinar. We'll move to the next part of this webinar, and I'll hand it off to Nishchal Reddy to take you through that. Nishchal? You might be on mute. Yes.
Thank you, Sudeep. All right. So I'll first be starting with a little bit of primer on zero trust. Right. I'll take some examples of the current patterns that a lot of organizations use for authentication and authorization, and I'll try to compare it with zero trust and how it differs and what advantages does it bring in, right? And then I'll hand it over to Rishi, who is going to talk about where Chef fits in, and how we can use Chef along with zero trust to provide that added a bit of authorization and ensure that the devices are safe and secure, right? And then he will also walk us through a small demo which will give a flavor of what zero trust would look like if implemented in an organization, right? So let's get started. So yeah, so at work, we use a lot of applications and systems, right? And we need ways to access or connect to them. Some of them are business critical, some of them are, comparatively less critical, and we can be a little bit less restrictive about their access. So we need different patterns that would support varying level of authentication. And like I said, we need a way to reach them, right? And the most common pattern to reach business applications and systems is you go to Office and you plug into your intranet, right? And you have access to everything that you need. And this also happens to be the most secure way to access business critical applications and systems. But nowadays, more and more teams and organizations are going remote, and hence this pattern is not sustainable or practical anymore. So we need other ways to solve this. And one way to do that is through virtualization with tools like VPN, which again is very common in a lot of organizations. So users enter the username and password, which will connect you to the internal network, and you'll get access to all the resources as if you're plugged into the network. And this is another common pattern where we have relaxed access, wherein some applications like mail, calendar, which are not so critical, right? And other SaaS applications, you can access them directly through single sign-on. Whereas a few other business critical applications like, let's say, production DB has to be accessed through VPN. So in a nutshell, two of the most important pieces are employees have multiple devices and have more than one way to get access to systems and applications through Ethernet, SSO, or using VPN. And this is where trust comes in, right? The trust assumption for a traditional model is either my employees are allowed in the building or their credentials are valid when they're connected over SSO or VPN. But there are some risks, some risk factors here. And these are the risk factors that zero trust is meant to address. First is, my credentials are stolen, and there is no way to validate if the person typing the credentials is indeed the one that is issued those credentials, right? And typically it takes, like 2 weeks to onboard someone, and also like 2 weeks to take them out of the system. So if you have a disgruntled employee, they may have access to critical system that could do damage to the organization. From a device perspective, endpoints are largest unaddressed threats because these are devices that move in and out of the building. Employees carry them along with them to their homes, coffee shops, and these employees include, super power users to all the way down to an intern. right? And we typically have safety measures like antivirus to be installed, have regular patching, etc. But the deployment and effective rate of these tools to run on a regular basis is questionable, right? It's been noted that device compliance status is one of the biggest growing risk factors, again, largely because of the way work has evolved over the last couple of years. And we have no way to know if they are infected with malware and if they are company owned devices. So this is what zero trust is set out to solve, and is one of the basic principles that never trust any user or device and always verify and validate at the point of access. So this is where zero trust comes in to solve the risk factors by putting in some logic into authorization flow that sits in between the authentication layer and the business apps we are trying to reach. And that pattern is called zero trust. So zero trust is a modern approach to endpoint security and is built on the basic principles of, you never trust and you always verify. Some comparison with older patterns, we used to let domain joined laptops to access business apps and resources. Whereas with zero trust pattern, we do additional checks, like if it is a secure laptop with to check if the laptop has AV installed and that the laptop configuration matches with what is approved by IT before letting them in. So, so let's take Google's Beyond Corp as a architecture reference for the rest of the discussion. The diagram here describes the pattern on a very high level. So employee has a device, and to access any of the cloud resources, the device must go through a rules engine and a proxy. They have depicted rules engine and proxy separately, but they can be in a single component as well. So let's see what a rules engine can do. It can validate device ownership. We can check patch level of the machine. We can measure security compliance. So the list of things it can do is really up to us. You can actually, at least some of the vendors provide ability to customize what you can actually do using the rules engine. You can check, really anything that you want. But what are some of the real world examples on how we can use rules engine to allow access to services and systems? Let's look at a simple example. Let's take a less critical system like email. So we might want to set some restrictions for a device to reach email. We want to validate credentials that the employee has are correct, and that it is a company owned device. And maybe we really don't care about their antivirus definition and the compliance status, as email is like a less critical system, right? So we can be pretty laxed about the policy. Now let's look at another example, right, for which we need some tighter restrictions. Let's take SSH as the next example. So this is, a little bit more complicated. Modern SSH does not use username or password or even public private keys that lives for a very long time. We often see certificates that are signed by a certificate authority that only last few hours at a time. To access sensitive information, we need some kind of a service that generates these one-time use certificates and is usually done through a credential-based system. So how about we make some improvements to do some additional checks? Number one is obviously checking the credentials. And then we can also potentially check if it is a company owned device. And then since, once they get access to these credentials, these certificates, they could potentially get access to some of the critical systems. So maybe we want to only, give access to generating those certs if the device is patched and is having the latest updates. All right, if you take it one step further, right? Now that we have sets downloaded onto the machine, the next step is to get actual network access to the machine, right? So network access is something that is more critical, right? So before we actually give network access, so we want to make sure that the device is not having any vulnerabilities and it is compliant. So this is where we can actually have multiple layers to this. And this is where we can do additional check to see if the device is patched, and we can also check if the device is compliant against standard benchmarks like CIS, which Chef provides, which is like an industry standard benchmark for most common compliance checks. And we can probably also ensure if disk is encrypted, screensaver settings are correct, so on and so forth. And we can also potentially check if the user is added to the right AD group to just double check that we're giving access to the correct user. And so these are some of the vendors in the zero trust space. Some of them provide capabilities to extend their rules engine to read data from different sources like Chef to ensure if the machines are compliant to certain benchmark standards, or you can also write your own custom checks. Whereas few vendors only support checks that they either provide out of the box or is limited to their product ecosystem. So going over the details of each vendor, what each vendor supports is out of the scope of this webinar. So and with that, I will invite Rishi to walk us through the next section, where he will touch upon where does Chef actually fit in this whole zero trust pattern, right? And he will also walk us through some of the foundational Chef components, the Chef infra and compliance language, and he'll also give us a short demo with a small example, which will give you a flavor of what does zero trust look like if implemented in an organization. So with that, I will hand it over to Rishi to take us through the next section. Over to you, Rishi.
Thank you, Nishchar. So, yep. So we'll try to get a little perspective of how Chef fits into this whole thing, and then we'll take a look at the infra and inspec. Okay. So you might remember this diagram from the slide earlier, which Nishchar was talking about. So what would happen is, in this case, Chef is going to handle all the device data. So whenever there's a run and the policy would be converged on the node would send back data back to our Automate server, and it will keep all the data preserved there. So whenever the user makes a request to the proxy, it would get the rules engine will process the policies and get the new data from compliance data, and it will figure out if the device should get access. So we'll take an example and we'll see how this would look like the whole flow, right? So in this case, you can see we have a user who is using a device that's registered as a virtual node in our Automate server. And what happens is whenever the user would try to request a service, let's say a database or a production server, any kind of service that sits behind this proxy, the request would go to the proxy, and that would in turn ask the access control engine, which has essentially all the logic to validate if the user should be given access or not. So how this would happen is the access control engine will get the request and it will have access to the policy. So it will say, okay, what is the policy for this service that the user is trying to access, right? And then it will have access to all these data sources, and it will probably have access to a corporate directory to get the details about the user and what kind of permissions they have. So this is where Chef comes in. So we could have Chef as our primary source of device context. And so whenever the node would give back, so let's say a Chef client run happens on the node would give back all the data to Chef server, and Chef server is going to store that. So whenever the user is going to make a request to the proxy gives it to the access control engine. Okay, you have all the logic. Should I give access to it or not? And then the access control engine is going to pull the access policy. It's going to take all the data sources, and it will figure out, okay, do we need to give access to it? So the policy may contain a couple of things, like did the Chef client run happen within 60 minutes? You can have 30 minutes, depending on how frequently you would like a Chef client to run. And then it can have things like that all the profiles pass without any critical failures. You can also check if the user has access to the server based on Active Directory listing. So yeah, once that policy, it would test the data against the policy. It will figure out, okay, should I give the access to the user or not? And that's pretty much how it would work. So now we'll take a look at infra and compliance, and how like a little bit more technical side of things. And we'll see a couple of examples of code, essentially of the kind of code you would write to get this working. So, but before that, we'll just talk a little bit about some of the concepts that you might probably know, but we'll just brush up on it. So a resource is essentially you could say the smallest piece of configuration that you could write to handle anything from package installation to creating configuration files to enable a Windows feature, create users, anything that is provided by Chef Infra. And we also have custom resources for desktop. So you could use that. We don't have a screenshot for this, but we do have a lot of resources for desktop, like setting a screensaver, setting up disk encryption, and there's a whole bunch of things you could do. And so the best thing about this is now, whenever you would do without Chef, you would have to write a whole bunch of scripts, handle it for all the operating systems. But this is what Chef does for us. So the whole resource would essentially figure out, okay, you want a package installed, and I'm going to figure out if this is a Windows system or this is a Mac system or is this Linux, and it would automatically do that for you. And another great thing about it is it's idempotent. So whenever it would run the configuration, if there's a configuration already set, it won't try to run it again. It will only see the current state, and it will see, okay, what is the difference, and then it will just apply what's needed. So that's two of the, you could say, best things about it. And then there are recipes. So they are nothing but just a bunch of resources stuck together to perform a set of operations that you would want in a machine. So you can see in an example here, we have Windows feature configuration, then there's a template resource that we're using, and then we are setting up a service. We are essentially enabling it, and you can see how simple it is. Instead of writing a lot of code, the resources have done it for us, and then we have just combined a couple of resources, and we have these recipes that we can run. Yeah. And then once the configuration part is done, we have Inspec that would handle compliance testing for us. So what Inspec would do is it's basically a compliance testing language. So it would take all the configurations that we have, and it will test again, test these against the compliance tests that we wrote. So in a normal scenario, you would write tools, like you would write scripts, and then you would try to run them again, probably maybe manually. So you could leverage, for this example, you have grep. So you could use it to figure out if the configuration is correct for SSHD or not. So what we have done is we have tried to wrap it in sort of a resource, and we could just write controls using the Inspec language and have a couple of more metadata attached to it that would help us in figuring out what the issue is. So anybody on the help desk or admin who looks over the endpoints, they can see, okay, this is the impact level. So you can see the impact 1.0. This is like a critical issue. So if it's not compliant, it will show it on the dashboard if there's any error. And when you become a Chef customer, so this is a screenshot from the Automate dashboard. So all the Chef customers have access to a lot of compliance profiles. So CIS releases security benchmarks that we take and we create Inspec profiles out of. And if you have, if you are a Chef customer with subscription, we would provide you all, like you'll automatically get all these profiles that you can just with one click, you could just run these on the node and it would work fine. So you don't have to worry about it. It's just it's very easy to get started with it. So to give you a complete overview of how this would look, so we would have a bunch of endpoints. We can also have a bunch of servers that are connected to a Chef server, and the Chef server basically has all the policies, and it would keep track of what nodes have been connected to it. So whenever there's a chef client run, the node would ask, okay, what is the policy that I need to run? And then chef server would give it back all the policies that it needs to run. And once the run is complete, it would get back the node data. And if there are any compliance tests, the compliance data would also come back. And all of that is stored in Chef Automate. So Chef Automate is a dashboard that you can also has a dashboard where you can see all the statistics for your desktop nodes, for your server. You can do a bunch of things like getting the compliance profiles. And so all of that is also accessible to through the Automate API. So it can be connected to your control engine, and it can work for the zero trust security. And this is sort of like all of this. You could write cookbooks that you have on maybe GitHub or Bitbucket, whatever you use, and you can have a pipeline setup. So all of these are automated. You can probably have release in stages, like you might release it to a couple of nodes, then you do a full release. So yeah. Okay, so now we'll move on to the demo part for Zero Trust. And just a small disclaimer, this is a pre-recorded video in favor of avoiding any hiccups that we might have. So you can see I'm connected to a CentOS server, and what we'll try to do is we would run sudo and try to get root access to it. But we want to check if we want to give the user this access or not. So what we have done here is sudo allows us to also set up some policies from sudo's configuration. So we have written a Python policy, and we have said that to connect to our Automate server and figure out if we want to give access to it or not. So it will just connect to the server, and it will figure out, okay, this is the policy, this is the compliance data that we received, and should I be allowing this to give access? So you can see it's saying it's not compliant. So we'll go to the Automate dashboard, and we'll check if what's the issue and how we can remediate that. So if we go to the compliance tab, you can see it shows this just one node for the demo. So you can see it says set a screen corner to start screenshot. And this is one of the profiles that's given by CIS. So we'll now just fix that and then see if we can actually see an update here, right? So here we'll set a hot corner for screensaver. So once this is done, we'll run the compliance test again and see if this actually works. So we'll run the sudo command as well. Okay. So now on the terminal, we'll just run the inspec command. So what this will do is it will ask the server to run the compliance test again on the nodes. So once this is done, you can see it says system is compliant because we indeed changed the setting to what it needs to be. And it said, okay, yeah, all the tests pass. And now if we see, it's going to allow us to have root access, and you can see the user switch to root. So yep, that's the demo. And with this, I'll give back the control to Nischal.
Thank you, Rishi. So yeah, that was a very simple example that gives you a flavor into how zero trust would look like when you have it set up in an organization, right? So beyond simply trusting a user through his credentials or through the device that he is accessing, you can go beyond that, right? You can actually perform different compliance checks. You can write custom checks to ensure and meet different specific standards that you want to adhere, that your employees have to adhere to, right, before even giving them access to any business critical systems. So now let me talk about Chef Desktop and where does it fit into Chef Desktop management, and then eventually into the larger Zero Trust pattern, right? So a little bit of history about Chef Desktop. It was launched in early 2020. So even before we formally launched a product, we had a lot of really large and popular customers who were using Chef technology to manage their endpoints. So what they've essentially done is they've looked at, they've been using Chef to manage their server infrastructure for a very long time, and they clearly, saw a lot of advantages using the Chef technology to manage server configuration, and they felt, hey, why don't we apply a similar pattern to endpoints, right? And we'll be able to get very similar advantages using that. And then they created this pattern where they use Chef technology to manage desktop configurations as well. And they've been largely very successful in managing like thousands of devices with a very small IT team, right? So looking at some of these success stories, we created a formal product offering around Chef to support desktop management as well. Um, so just moving ahead, yeah. So Chef Desktop is an automation solution that is built to empower IT resource managers to automate most of the manual tasks and to gain better control over their IT resources, and also reduce the security risks and compliance risks. But how does it do it, right? So you can use, if you look at Chef, right? Chef primary principles are, uh, config as code, policy as code, right? So we have applied similar patterns and principles to endpoint management as well. So now IT admins don't have to really fiddle with the UI and different menu options or point and click kind of a tools. They can actually automate most of the manual tasks that they would otherwise have to do via code, right? So they can totally automate desktop management via code, and not just that, they can actually set up CI/CD pipelines and create proper SDLC process, so that even before any change is pushed to real devices, it is peer reviewed and it is tested in some kind of a staging environment, and only once all the tests are done properly, they can push those changes to the production devices, right? So they can have proper SDLC practices around endpoint management as well. And then so they can also manage company-wide devices with single tool chain and processes. So they can use exact same methodologies of writing cookbooks, writing resources to manage multiple operating systems like Mac, Windows and Linux. So otherwise you'd have to fiddle with multiple tools which have different user experiences, different processes, and different methodologies. And not just applying and managing configuration, Chef has this inherent ability to automatically detect configuration changes, right? So uh, so if um, so let's say if you have defined a desired state for your fleet, and if any of the endpoint in that fleet deviates from the desired state, if the configuration changes because of some reason, maybe system error, or maybe user has found a way to change the settings, then Chef can automatically detect that, and then it can also correct it. It will try to bring it back to the desired state. And then the Chef being code first is heavy. It can be heavily customized and highly extensible, so you can really meet any of your organization's unique needs. And then you can also configure and manage non-traditional setups like air gapped environments, so on and so forth. And then, like I said, since it is code first, you have maximum flexibility. You can write your own custom cookbooks, custom integrations, even the ones that we don't provide natively. And then, like I said, since you can use Chef to manage multiple operating systems, it gives you a single pane of glass through which you can get visibility into the whole fleet, not just a specific operating system, right? And then you can also drill down into different views and layers to find more details about if a node has drifted from a desired state. You can find out the reason why it has drifted, and if Chef was able to bring it back to the desired state, or if not, you can go and correct it back. And then You can also correct any, like I said, any configuration drifts, but it also provides you a compliance posture of your whole fleet as well, which I think is a good segue to the next section. Not just managing your endpoint configuration, but Chef has a product called Chef Compliance, which can be used to also continuously monitor compliance posture of your fleet. Right, so you can consistently enforce any security and company policies on your fleet. You can also we provide a host of CIS benchmarks that you can use right off the bat. But if you have any custom organizational needs that your security or compliance teams want to enforce, then you can also extend the existing policies, or you can write your own custom profiles and controls to support those needs. And then you can also Chef Compliance not only monitors for compliance adherence, but you can also set up auto remediation, right? So let's say if an endpoint is supposed to have 10 seconds for screensaver setting, and for some reason it got changed to 15 seconds, you can write remediation content to bring it back to the desired state. So and Chef Desktop also supports these features. You can do zero touch enrollment and provisioning, and you can also automate app deployment and management. You can also automate policy settings, and like I said, it provides high flexibility. You can fine tune it to your needs, and it also provides you like a single pane of glass where you can look at all the consolidated information and insights. You'll also be able to set different enforcement policies and configuration profiles via Chef Compliance, and you can also enforce or check if all the endpoints are meeting that policies or not. You can also check things like if the device has proper data encryption setup, if the device has antivirus installed, or if the device has all the system updates installed or not, right? And it supports multiple operating systems, Mac, Windows, and Linux. So with this, I'm mostly done with the webinar, but I would like to remind that we have another poll that will be coming up on your screen. So please do answer that poll question. We will be discussing the results in a moment. So all right, so maybe I think this is a good segue to Q&A before we come back to discussing the poll.
Great. Thanks, Nischal and Rishi, for that demo and overview, right? So quite a few questions. The first one was, I have a zero trust provider already in-house. Can I integrate that with Chef?
Got
Nischal,
it.
do you want to take that?
Yeah. So that's a good question. It really depends on what zero trust provider that you're currently using. Like I said, a few zero trust providers provide high flexibility to do any custom checks that you want, or integrate with other tools like Chef to look at some data that these tools generate to take decisions on whether to provide them access or not. And there are a few zero trust providers which only work within their ecosystem, or which work on only the capabilities that they provide out of the box. So it really depends on the kind of zero trust provider. But if your zero trust provider has that extensible capability, then you can definitely integrate with Chef to look at Chef's compliance data to take those decisions whether to provide access to the user or not.
Great, great. The next one is, what compliance profiles does Chef support for endpoints?
Got it. So as discussed a couple of slides back, we provide CIS benchmark profiles, which is like industry standard. We support CIS benchmark profiles for a wide range of operating systems, both server and workstations. But apart from that, we also have a lot of customers who have implemented their own custom compliance profiles and controls based on their organizational need, right? So it is pretty easy to write custom controls. You can use Chef Inspec to write them, and you can apply any custom requests that you have from your security and compliance team.
Sure. There's another one. This one is, hey, this is regarding SSO integration. Do you have any admin guide or any content that they can refer to with Chef?
Sure. So maybe I would like to know more details about this particular use case. So, for example, Chef has something called Automate. It is like the visibility layer, the reporting layer, where you can go and look at your fleet status. You can check if the fleet is compliant or if the fleet has all the latest changes or not, and all that. So, if you are looking to have some kind of SSO integration with that visibility layer, then we do. I think there are certain resources that we can share. But if it is something else, maybe if you can elaborate, then maybe I'll be in a better position to answer that.
Sure. Let's hope that the person that asked that question can provide some more context. But while we do wait for that, the results are in for the poll. Raisa, could we have those results up, please? Well, this is interesting. The first one, what's the most critical challenge in ensuring zero trust with your laptops or desktops? And an overwhelming 63% are saying limited visibility to configuration drifts of the fleet. Of course, it's equally distributed with the other three options, but Nishal, looks like limited visibility to config drift. Would you want to talk a little bit about that in context of what Chef does?
Yeah, this is interesting, and I think also it is kind of obvious at the same time. That's because if you look at traditional endpoint management tools and MDM products, right, solutions, right, they're really good at a few things, and where they have a gap or where they lack is so using these tools, right, you can enforce certain configuration. You can say that I want screensaver to be 10 seconds, or I want screensaver to be 20 seconds, or I want to deploy the script to set some settings on the endpoint, right? You can deploy such scripts. But what happens after those settings are sent to the endpoint, right? What happens if the endpoint moves from that desired state to or drifts from that configuration to something different? Endpoint management tools and MDMs really don't do a great job at that, right? So they don't have really the MDM pattern really doesn't have a great methodology to solve that, right? Solving configuration drift is not really MDM tools and endpoint management tools are not good at configuration drift, right? I think this is where Chef has a unique edge, where drift management or configuration drift management is like inbuilt into the Chef client, right? So Chef client will pull all the configuration changes that it has to apply on the node from infra server. And as soon as it is done applying, it will periodically keep checking if the endpoint is in the same state or not. Right? If it isn't, then it'll try to apply the exact changes that have been drifted, right? That way it can optimally try to bring the node back to the desired state. So yeah, I think it is no surprise that a lot of people have called this out, because this is an inherent gap that some of the traditional management solutions have. And yeah,
Sorry, go on.
I was trying to touch upon the next point, which is dependence on devices to check in via VPN. I think this is something that has become more prevalent recently in the last couple of, I would say, an year or so. Right. So if you look at how most of organizations were managing endpoints, right? They were managing endpoints using your traditional endpoint management tools, which used to work via. I mean, those tools used to manage endpoints when the endpoints were connected to your intranet, right? When they were within your network perimeter. But when the pandemic hit and we were forced to go remote, so the IT teams still had the same archaic, management tools, and they've started relying on VPN to manage the endpoints. So they are now reliant on employees to be connected via VPN to manage them, right? Which is not an optimal way to do it, because you can't really control that. It's not in your control, because employees, I mean, nowadays, employees can do their work by accessing a lot of SaaS applications, which doesn't really require a VPN, right? All you need is an SSO. right? That's like a
Correct.
norm, right? Now, so you really can't force your employees to actually, log in via VPN or enforce them to be logged into VPN all the times to manage them, right? And this is one of the primary reasons why a lot of laptops go out of the desired state or complaint status, and which will cause a lot of trouble to the IT teams to go and manually fix them, right? And in a way, Chef can solve this because Chef can work outside of VPN, right? So what you can actually do is, if you currently have some of the traditional endpoint management tools that work via VPN, you can still continue to have that, but you can deploy Chef client via your endpoint management tool for the first time, right? And from that point on, Chef can take over, and you can actually automate most of your manual tasks, and then you can rely on Chef to do most of the configuration stuff. So that's one pattern that we've seen some of our customers apply as well.
And just briefly touching on the third option, right? I think the subtext to that is there are fairly large names that operate in the Windows space or in the Mac OS space, but really nothing at all in terms of trying to enforce zero trust or orchestrate zero trust in Linux as a platform, right? And a number of our respondents are saying implementing zero trust across a large fleet running diverse operating systems is a challenge. Do you want to touch a little bit on that, especially in the context of Linux devices?
Sure. Yeah, I think Linux is an interesting thing, but it goes beyond that as well. So let's talk about Linux first, right? I think if you look at the major operating systems for workstations, I think the biggest share goes to Windows, and then followed by that Mac, and then Linux, right? Although Linux is not having a huge share, but Linux is still used as workstation to build some really mission critical systems. And we've been speaking with some of our customers who are using it to build some really cutting edge and bleeding edge technology, right? And that technology, the tool chain required to build the technology is only on Linux. So they use so some of our customers have like 50% of their fleet as Linux workstation machines, right? And there is a huge unmet need in this space, where there are a few solutions, but they're not ideal because of the sheer number of Linux flavors that are out there, right? So there is no uniform way of managing all of them. And this is a unique this is a place where Chef has unique edge. So Chef has been used to do configuration management on Linux servers for a very long time, and different Linux flavors at that, right? And then we support a wide range of popular Linux flavors, and not just Linux. It was also being used for managing Windows servers as well, but here in the context of Linux workstation. So the point I'm trying to make is it has been used to manage configuration on Linux servers for a very long time. And it is very natural and very easy to take and apply the same processes, tools, and even to a large extent cookbooks that were written for servers on these workstations as well. So it's like easily transferable skills, not just skill set, but also existing cookbooks that were built, right? So I think Chef can really fill that gap for Linux management. And just extending that, right, to other operating systems. If you look at most of the tools, you have if you look at any typical organization, right, they have a different tool for Mac and different tool for Windows to manage their machines, right?
Correct.
And they really have to do a lot of context switching but between these two tools, more so if you have a limited number of resources and people in your IT team, right? And the way you do something in Mac is like completely different in how you do on using a tool that you manage your Windows machines, right? I think this is where Chef provides really great abstractions, that would leave out all the implementation details from you, and you can really only worry about configuring the settings that you want to configure, right? And Chef abstractions or Chef resources can handle the laborious job of actually going and figuring out how to do it for individual operating systems, right? So it doesn't mean that you can't write resources or cookbooks for individual operating systems. You can also do that if there is a need, but you can also use existing resources, or you can write cookbooks and resources for which are common across different operating systems. That would really increase the productivity of your employees, because they don't have to do it different ways on different machines, right? It's just so streamlined.
Correct. Great. We are just time check, right? The gentleman that asked the question on the single sign-on integration, we've just dropped a link that you can access, and probably that's helpful as well. In the meanwhile, could we have the results to the next poll, to the second poll question, please? This is very interesting. So what are the major challenges faced with managing desktop and laptops? It's even Stevens, but fairly high at 71% in terms of visibility to the status of the fleet, and enforcing compliance standards on end user machines. That last one, ensuring compliance standards on end user machines, can be fairly painful, right? And it also goes back to the whole VPN conversation that you brought up, Nishal. Maybe you want to talk a little bit about that.
Yeah, I think it goes back to a lot of things that we've discussed for the previous poll, right? I mean, uh, so like I said, typical organization has multiple tools to manage different operating system that just becomes so hard to get status of the fleet, right? Where do you go? You have to go to different tool to find something, and then you have to go to other, and then you have a completely different tool for getting your compliance, posture of your fleet, right? And how do you make sense of out of all this, right? And then we've also heard some of the people using traditional tools, right? So let's say if your complaints tool gave a report saying John's laptop is out of compliance, right? They now open, and John is using Windows, right? Now they open some kind of Windows management tool to write some script to remediate that problem. So it's like juggling between multiple tools, and then also getting the visibility into the whole fleet is just so hard with too many tools at hand.
Great. And just quickly, right? Remediation is also coming up fairly high, right? So how do you get desktops and laptops into their desired state? And you can do that right from the dashboards that we have. Nishal, do you want to talk a little bit about that as well?
Yeah, so actually, like I said, Chef Compliance can not only check for the compliance state of your fleet, but you can also, use some of our remediation content that can actually fix any issues that your, Chef Compliance finds, right? Not just that, but you can also extend, or you can write your own remediation content or remediation cookbooks to fix any custom issues that are specific to your organization, right? Let's say you're using some different kind of VPN that is not very traditional. This is just a very bad example, but I'll just go with that. uh, and then so this is not supported out of the box with the compliance profiles and remediation content that Chef provides. You can write your own remediation cookbook to actually correct those settings to bring it back to the desired state. So you can actually use the ones that we provide off the bat, or you can really customize it to any extent that you want.
Great. I want to be cognizant of time, and I know we're up on it. But thank you, Nishal and Rishi, for presenting this, and to everyone that participated for your time. With that, I'll hand it back to Raisa.
Thank you, Sudeep.